This is note-taking guide 4.8 for Math 2. We're solving systems of equations by any method. So on number 1, when you look at this and we're going to solve a system of equations, I would definitely use the elimination method, because these two equations are already lined up. Your x's are in one row, your y's are in one row, your equals and your numbers are all set up. So it's ready to just see if you can add straight down and cancel something. This one's actually set up so that these will cancel. The 3x's will cancel if you add them straight down. So we don't even have to multiply through by a number. So if we add those straight down, those add to 0x. If we add the y straight down, we have a negative 1y. And if we add the number straight down, we get 2 minus 3, which is a negative 1. So to solve for y now, I'm just going to divide both sides by negative 1, and I get y equals positive 1. I'm not done yet though. I have to find my x value, so I have to take it and I have to substitute it back into one of my original problems. I'm going to use the bottom one just because it's all positive on the one side and I want to just be easier. So I would have 3x plus 3 times 1 equals negative 3. So 3x plus 3 equals negative 3. I'd subtract the 3 over and get 3x equals negative 6. And then divide by 3 to get x equals negative 2. So my answer is always in an ordered pair x comma y. So my answer is going to be negative 2 comma 1. You can always check to make sure you did this right by substituting them back up into both of the top two equations and making sure that your equations get the correct solution. Alright, number 2, if you look at them and you try to add them straight down, nothing's ready to cancel right now. So you have to look at it and you have to decide whether or not you want to get rid of your x's or your y's. When I look at it, I want to do something with those y's right there. Because I know if I already have a negative 5 there, I can easily make this one right here a positive 5 by multiplying through by positive 5. So that's what I'm going to do. I'm going to multiply that top equation through by a positive 5. And I'm just going to rewrite it down here where I can see it. So 10x plus 5y equals 100. I'm going to cross that one out to remind myself I'm not using it when I add straight down. And I'm going to combine these two equations together. My 5y's cancel, that's why I did that math in the first place. Over here I get 16x, and over here I get 112. To solve this, I'm going to divide both sides by 16. And when I do, I get x equals 7. I'm not done yet though. I do have to substitute that 7 back into one of the two original equations. So I'm just going to rewrite that top equation down and substitute 7 in place of the x. So I'd have 2 times 7 plus y equals 20. So I'd have 14 plus y equals 20. And you can tell already that the number is going to be 6, but subtract 14 from both sides and you get y equals 6. So your ordered pair for this answer is 7, 6. Again, you can take that and substitute it into the first one and the second one to make sure it satisfies both of them to know that your answer is correct. Alright, this next problem right here, it's not set up for elimination. You can tell because when you look at them, they're not stacked together right. But this is an x equals equation right here. And x equals negative 3x plus 3y. So we can take that and we can substitute it in place of the x in the other equation. So I'm going to do negative 7 times x, but instead of x, I'm going to do negative 3 plus 3y. And then continue writing that other equation down. So plus 8y equals negative 5. And I'm just going to solve it from there. Have to distribute that 7 through. So a negative 7 times a negative 3 is a positive 21. Negative 7 times positive 3 is a minus 21, and then I have the y attached to it. I still have plus 8y, and then equals negative 5. I'm going to combine my like terms on this side. I have a negative 21 plus 8, so I get a negative 13 on my y's. So I have 21 minus 13y equals negative 5. I'm going to continue to solve this by getting y by itself. So I'm going to subtract the 21 over. And I get a negative 13y equals negative 26. Divide both sides by negative 13, and I get y equals 2. I'm still not done though. I have to go and substitute it back up into the top in order to get the value for my x. So I'm going to put it up here in this x equals negative 3 plus 3y equation. And so x equals negative 3 plus 3 times 2. 3 times 2 is 6. Negative 3 plus 6 is 3. So my ordered pair answer is 3, 2. All right, one more of these systems to go before we do a couple of story problems here. This one actually could be solved by elimination or by substitution, either way you want to do it. But anytime it's set up for substitution, I like to just use what's set up for me and solve it that way. So I'm just going to substitute the 3x plus 4 in place of the y. So I have 3x plus 4 equals negative x minus 4. And I'm just going to solve this now. I'm going to subtract 4 to the other side. And I have 3x equals negative x minus 8. I'm going to add the x over to the other side. So I get 4x equals a negative 8. And then divide both sides by 4. So my solution for x is x equals negative 2. I'm not done yet though. I got to take that x and substitute it back into one of those top equations. So I'm going to pick that top one up there, 3x plus 4. I'm going to have y equals 3 times a negative 2 plus 4. 3 times a negative 2 is a negative 6. Negative 6 plus 4 is a negative 2. So my y equals negative 2. My ordered pair solution is negative 2, negative 2. Now this should have all been a review because we've been working on this for quite some time now, so hopefully I didn't move too fast for you. What we're going to do now is take our knowledge of solving systems of equations and we're going to solve some story problems. Now the one thing I don't like about story problems is they usually give you too much information, more than you need to know. So we're just going to read these and we're going to see if we can figure out what we really need to know and then write our equations. So number 5 says, find the value of two numbers if their sum is 12. Well, first of all, we need to decide what our two numbers are. So maybe we should call our numbers x and y. And then we need to decide what sum means. Sum means add. So if the two numbers sum to 12, then we know x plus y equals 12. And then it also says that their difference is 4. Well, difference means to subtract, which means x minus y equals 4. So we have a system of equations here now, and this one's actually set up for elimination if you look at it. We can add these equations straight down, and we can get our solution just by doing that. So x plus x is 2x. The y's cancel each other out, and I'm equal to 16. I'm going to divide by both sides by 2, and I get x equals 8. Once I find out what x is, I can substitute it back into one of the two original problems. So x plus y is 12. If x is 8, then y would have to be 4. So my ordered pair solution would be 8, 4. All right, this next word problem has a ton of words in it. We're going to just kind of not worry about the words and see if we can find the math in there. So it says the state fair is a popular destination, and I say, like, who cares? Like, that doesn't mean anything to me. This year, the senior class at Snow Canyon High School and the senior class at Dixie High School both planned trips there. So really, that's not any math yet either. The senior class at Snow Canyon High School rented and filled 8 vans and 8 buses with 240 students. So that looks like an equation to me. If I use V for vans and B for buses, I would be able to write an equation that says 8V plus 8B equals 240 students. I'm going to do the same thing with the next part that it's talking about. This time it says Desert Hills or Dixie, whichever school this one really is, has 4 vans and 1 bus, which is 54 people. So 4 vans plus 1 bus equals 54 people. Now we have a system of equations that we can solve. So it's set up for elimination the way we wrote our equation, so I'd like to solve it that way. We need to decide if we're going to get rid of our v's or if we're going to get rid of our b's. I think just to make it easier right here, I'm just going to multiply by -2 on this equation in order to get rid of my 8 in the front. So this will be a -8v minus 2b equals 54 times a -2 is a -108. So I'm not going to use that equation anymore. I'm going to use this new one that I wrote, and I'm going to add straight down so that I can get my new equation. My 8's canceled, and I get 6b equals 240 minus 108, which is 132. Now I'm going to divide both sides by 6, and I get b equal to 22 students. So in each bus they had 22 students. We're going to figure out how many people they had in each van by substituting back into one of the 2 original equations. So I'm going to use the second one this time. 4v plus b equals 54. So if I have 4v plus 22 equals 54, I'm going to subtract that 22 to the other side, and I get 4v equals 32. Divide both sides by 4, and v equals 8. So 8 people in the van, 22 people in a bus. Okay, the next equation is set up just like that. I'm going to make sure that you have your equation set up, and then I'm going to just let you solve this one on your own. It's the exact same problem. The only thing that's changed is the numbers. So 1 van and 6 buses is 372. So 1 van plus 6 buses equals 372 students. And then 4 vans plus 12 buses equals 780 students if you read the information inside there. So you're going to solve this system of equations on your own so that you can get full credit on your note-taking guide. This last equation right here is talking about selling musical tickets to the musical at school. It says Zach's school is selling tickets to the musical. On the first day of sales, the school sold 3 senior citizen tickets and 9 child tickets. I'm going to call the senior tickets S and the child tickets C. We sold a total of $75 worth of them. So we know the senior plus the child equals $75 on the first day. And then the school took in $67 on the second day for 8 senior and 5 child. So 8 senior plus 5 child equals 67 on the second day. So this problem again is set up for elimination, and we've done elimination like 5 days in a row, so I'm going to let you finish this problem on your own. Just a little hint again on these word problems, just look for the math in them, kind of ignore everything else. Look for the math, set up your equations, and then solve them. Thanks for watching, guys.